This season, Bridgestone will provide every rider with 18 slick tires at each Grand Prix, giving riders a choice of 2 slick tire compounds for each Grand Prix. Riders receive 8 front tires, of which they can choose 4 of each compound, or 5 tires of one and 3 tires of the other. Each rider also receives 10 rear tires, 5 of each of the 2 available compounds. The softer of the slick tire compounds is marked with a white line around the sidewall. Each rider also receives 4 front Bridgestone wet tires and 4 rears of a single compound, or 5 of each if every session is wet. All the tires are allocated to riders one day before each Grand Prix starts by the governing body to ensure impartiality and fairness for all riders. Bridgestone slick tires are available in 4 compounds: soft, medium, hard, and extra hard compounds, with an additional 3 asymmetric rear tire compounds: medium, hard, and extra hard. Asymmetric tires are designed for asymmetric circuits that generate higher tire temperatures on one side of the tire than the other, and they require a harder compound in one shoulder with a softer compound in the opposite shoulder. Bridgestone's wet tires are available in soft and hard compounds, but only one compound is selected for each Grand Prix. Compound hardness is a trade-off between outright grip and durability. The type of circuit plays a key role in Bridgestone's choice of tire compounds for each Grand Prix. Softer compounds are used to enhance warm-up performance when the conditions are cooler or the track surface is smoother, whereas harder compounds are used in order to maximize durability when the conditions are hotter or the track surface is more abrasive. 2 Bridgestone tires are all that connect each MotoGP machine to the tarmac, and they play a crucial role in performance. Let's take a look at 3 situations in which they're put under pressure. The final corner of Australia's Phillip Island circuit is one of the most demanding of the season for the rear tires because it is fast and long, and this puts the left shoulder of the rear tires under great lateral load. As the rider accelerates through the corner, the left shoulder of the tire reaches the highest rear temperature of the season. By contrast, the right shoulder of the tire is not in contact with the track surface and so remains much cooler. The opposite is true in fast right-handers like the last corner at Catalunya, but rear tire temperature is equally high as riders accelerate mid-corner at high lean angles. In both instances, one shoulder of the tire clearly operates at a higher temperature than the other, and this requires the use of asymmetric rear tires. Excess temperature can have a negative effect on performance and durability, so asymmetric rear tires use a combination of harder and softer compounds in the 2 shoulders to provide the same level of grip at very different operating temperatures. The front tire comes under pressure too. Under heavy braking, such as for the last corner at Sepang, it is the front tire that does most of the work. As the deceleration moves the weight of the bike and rider forward, it is all concentrated on the front tire where the braking energy is turned into heat. On corner entry, the focus of the load moves from the center of the tire to the inside shoulder. But as the rider starts to accelerate out of the corner, the load starts to transfer from the front tire to the rear tire. With all these variables, the team and rider, along with Bridgestone engineers, must find a way to use the tires within their optimum temperature range so that they can deliver peak grip and durability, leading to better lap times.